Alright guys, I'm ready to get this thing started. Thank you for joining us on this mill turn webinar. I'm going to get into it pretty quick here, but I will say that if you guys have any questions along the way, feel free to enter them into the panel, GoToMeeting panel there, GoToWebinar panel, and we'll get to those at the end and we'll pick some questions. And if you don't get picked, of course, you can always phone your local reseller and ask them as well. I'm going to get right over to Gibbs here, and I have the part that I'm going to be demonstrating here, and you can see kind of the full out setup where I have a whole machine sim, the machines in there, fixturing, there's tool blocks, all of the tools are well defined, and this webinar, the purpose is just to show off how very smooth and simple it is to go between milling and turning when you're using a machine like this that has obviously turning, but also live tooling in most situations. And in situations, it can get even crazier than that with milling heads and lathes and stuff. So we're going to focus in on a single turret and a single spindle. And I'm going to walk through and just highlight all of the little things. I'm not going to go too much into training mode here. I just want to get the point across of how it can be used, and we can go from there. Right, so the simulation itself, I'm not going to have that in the file right away, but you can get an idea here where it's really ops on the face, the OD, anything that you would expect to see. All right, so I'm going to open up a file. So I do have files that I'm going to be loading just to keep things smooth and kind of running on time here. So the file really doesn't have anything done to it other than I've selected the machine quickly, I've put in the stock and clearances. I've even brought in a fixture here just to show you that you can do that. Bring in a model, download it, whichever, very easy to use. And you can hide it, doesn't have to be shown at all. All right. And I'm going to bring in a part as well. And the part, when you're cutting something, it can be a model like I'm going to bring in. Right, so I'm just going to import my part in here, and you'll see a solid representation of it. But you can import wireframe geometry, you can draw wireframe geometry, you can dimension, modeling, all that can be done in GibbsCAM. So wherever you end up starting, you'll have something to cut in the end and to apply the actual tool paths to. Right, so you can see here everything's nicely defined. Now once you have your part in here, there's lots of very good display preferences. You can hide things, show things, colors. Really the whole interface is very customizable. Anything can be moved. So I'm using the default layout. But just know that as I go through, you can change it and add shortcuts and all of that good stuff. Moving things around is also very simple. There's a view palette that you can use. I prefer to use shortcuts and my mouse or a space mouse. They're all available. They can all be customized so that it's the same as other softwares too, which I find is very important when you're switching between them. Okay. So first thing I'm going to do is I have this chuck here, and I'm just going to send it to this thing called the body bag. So that's a little manager for the solids, and there's different levels as well that I'll get to when I'm engraving something. All right, so all the good stuff is there, and it's very easy to access here and even on the default layout. Now, you can see my part didn't quite come in the proper way here, and there are plenty of tools to move things around, to locate your part, rotating, translating, all the good stuff, and some little shortcuts too. So this does come up to for me, depending on how the CAD modeler has modeled things. It could possibly come in the wrong way, and I'm just going to go in and bring up the CS list. So these are coordinate systems, and you'll see them come up again. But basically just a machining plane, and I can go ahead and maybe align this part to that plane. And it just takes some of the the angle out of it. Even if it was a severe angle, you could do a multiple lineup and line up to one plane and then the other, and then be ready to go and machine your part. So I'm happy with this. It looks like it's in the right orientation. There are plenty of tools to check it, but I know I'm good, so I'm going to go ahead with that. Now, I want to cut, so I have something to cut. Now I need something to cut with. So that's when it comes into the tools. So I find the workflow with Gibbs is very, very easy to understand. It doesn't really change whether you're doing turning or milling. You can see here that when I make a tool, first thing you do is you pick a tool form. You can see in these cases we have some milling tools here, so that would be live tooling in our situation. We have our turning tools, and we even have some broaching, some linear and some rotary broaching in there. And all of these do have a form tool equivalent, as well as the tool holders. So you can draw, you can import a wireframe or a model and apply that as your tool shape as well. All right, once you pick something, you fill in the size, fill in the holder information, and then you give your offsets, can give a little comment, and every tool is like that. So if you're making a tool from scratch, it's very simple. It's easy to find your way around. Now, as you get into programming, the better thing would probably be to have some way to bring in tools. So I'm going to be doing that coming up. So you can definitely load tools and all that good stuff as well. All right. Let me just pick maybe a standard insert here. Tool holder on it there. And you can see the preview is all nice and 3D as well. Boring bar. So once you have a tool, whether it's a milling tool or a lathe tool, you bring it down to what's called the process list. And this is really where everything gets added together and set up before you actually make it into a tool path. Now, depending on your license, you may or may not have everything that you see on my screen. But this is how it works, where you either drop your tool down in here and you get access to the process types, or you can go it the other way around and double click here, select a process type, and it will filter through all the tools it thinks you can use, and you pick it, and then it all gets there in the end to a dialog that would set up whatever you're setting, whatever your tool path process type is. All right, so whether I'm doing a contour here or roughing, threading, there's elliptical contours. I mean, there's a process for pretty much everything. So we're going to stick to certain ones here, but if you don't see the ones that you wanted to see, then obviously you can put in a question or ask your local reseller. Now those as well are loadable. So you know, the best way to do it, I mean, you have to make your tool most likely at some point, but I actually have my tools and my processes created, again, to keep things smooth and keep things under the time limit. So you can load tools here, and there's tools that you can save yourself. You can also use different plugins, like Sandvik has Cora Plus. There's also the Helical Solutions and the Harvey tool, the libraries here, and some other solutions for that as well out there. So in that case, maybe I have a process already set. You can see here I've created a folder, and it's just Mill-Turn webinar, but I'm going to go ahead and load out of that. But you can make your own folder system by machine, by material, by tool type, whatever you'd like. And when you load it in there, then you can see if I load a tool, I get the tool. And if I load a process, I get the tool along with all of my parameters filled out already. So that could be anything from feeds and speeds to what type of process or what type of cut you want to do, right? So the one that I've imported here is the facing process. All right, so we're going to put that onto our model. And again, the workflow is always the same. You'll see as I go through, make tool, drop tool down, pick what tool does. You get a dialog. Everything's all in that dialog. There's no hunting around trying to find different things. And once things are filled out, then you can apply the actual toolpath to the part. So that's the place I am at right now, and depending on what process you use, there's different things to select. So I could be maybe selecting the model, or I could be selecting some wireframe geometry. I may extract some geometry from the model. If it's already drawn, I can use that. In this case, I'm going to bring up something that's used to turn on solids. That's very useful, actually. It's called the profiler, or the slice plane. And it has a certain mode. So if you see the slice plane just as it is, you can see that it slices through. And it's not really what I want to use to turn this part, because if I turn this guy, then obviously it's going to gouge in the higher areas. So what I'm going to use is I'm going to turn it to slice fun body mode. And that one's really great because you can never bring that slice plane off zero, off the center, so you know your diameters are right. You can also see that it's showing all of the highest points. So it's showing all of those and getting rid of anything that you can't hit while it's turning, while the part's spinning, like these holes are not being sliced anymore. And you can extract geometry off of that, or you can just go right in and use the profiler. All right, so that's going to be what I'm going to pick for this specific toolpath. So a contour or roughing, anything with a specific shape is usually going to need some kind of a profile like this or a model. Now when I'm applying, in this case, we have our lathe processes use these start and end markers that are quite easy to use, really. That's just about where you want to start and where you want to end and what direction you want to go. And then whether you want to go all the way around or one skim on the face, let's say, like this. I'm ready to do the toolpath right now, but I will mention that you can move these by specific amounts and all that. You might see that come up. I'm just going to kind of place things where they are and rely on this material only to prevent any air cutting. All right, even though I drag this up here, when I do the toolpath, you'll see it avoids that. Now, once I'm ready to make the operation, finished operation, notice my list over here, which is the operation list, is empty. So I'm going to go in, I'm either going to say do it, or anywhere I right click, there's a do it. All right, and if I click that, you can see the toolpath appears, and I have my finished operation over on the side. Now, if I wanted to change something about this, then that's when redo comes up. Right, so there's redo, which will recalculate the toolpath based on whatever changes you made. So if I didn't want to go down as far, let's say, you can see that it shortens that guy up. But once again, it knows that there's material being removed, so even if I drag it past that center mark, it doesn't go past. I can always override that as well. So that's the gist of adding the toolpaths, and I'm not going to go into much about, what each thing does, because I get into training mode sometimes. But I'm just going to clear this off, and I'm going to go ahead and check out the simulation now. Right, so we have an operation. I'm wondering, I want to watch that. So what I can do is come up, start my sim, and there's a couple different simulation modes. There's the one that you saw with the whole machine and everything, and then there's the one that back plots. You can rewind and play, and this one is also a nice one called OpSim, and we'll just show whatever you want to play with tons of useful options. I'll bring them up as I look through the rest of the toolpaths, stopping anywhere you want, different colors, checking to see if the simulation matches the part, etc., etc., etc. All right, and you can see, even though my picture was hidden there, it's showing in the sim, and I can always turn that off as well, or make it transparent or anything like that. You can see I have every little part in there of that picture. So I'll pop in, and you get to the point where by just looking at the toolpath that's probably going to be fine. And if you see a little line going right through the part, then that's probably when it's bad. But I'm going to try not to do that. All right, so I'm going to load a couple more in here, and again, not going to dwell too much in it, but here's some roughing and finishing, let's say. So you can see these are stacked together. and they'll apply to the same selection that you make. And this one, obviously you can do roughing and finishing tools, absolutely, but here you can see that that one's using the same tool and it recognized that, so it's going to go ahead and not make me another tool or a duplicate tool. And this one's going to go ahead and rough this in. All right, so I'm going to start picking things out here, and depending on what you want to rough, again, there's little shortcuts. You just do something like that, and that selects everything that I want to cut. And I can say do it, and you can see it generate the cut there. And I have 2 more operations. And again, I can pop open the simulation if I want. I can play it, and I can kind of check, is that okay? Anything crashing at all? And I actually put on this one, it's hard to see, but there's a chip breaker. I thought about using the pull-off, but again, there's lots of options in there once you start digging that you can use. But nice and easy. I got my thing. My OD is turned. My face is turned. Again, this is a demonstration, so don't give me too much stuff about the actual methods. I might cut things differently in other situations, but let's move on to doing a little bit in the middle here. So here's an example of one process that doesn't even need anything to be selected, right? So what it is it's actually the U-drill in this case, but you can see here when I have a tool that can do both, I have a live tooling drilling, and then I have a on-center with chuck spinning drilling, right? So one's going to give me the on-center, and that one obviously it can't go anywhere but on-center, so that's why I can just go ahead and say do it, and I don't actually need to select anything. I'm going to go ahead again, maybe I'll do some rough and finish and threading. And again, these guys, if you're making them by hand, then great, but definitely save them if you can. If you use that same material, especially those same tools all the time, you can even have your whole tool list in here and possibly your whole machine sim set up before you even have any kind of thing going on where, you might have a template file or something like that you don't even have a part in and you never change your tool locations. That's all doable, all doable. And here again, you can see the material only, picking up that there's material back here. And again, if I didn't want to go back all the way, I could always redo, just kind of shore it up, and it's very quick to just redo or redo with a redo shortcut. Again, checking all the way if you want, or doing the whole program and then checking is perfectly fine. But for any inner diameter work, you can see there's a little cutaway, so I can actually see what's going on inside. You can see that, yes, that's cutting, and then obviously looks like the thread's going on in there. And the transparency could also be used as well. I'll play it all a little slower when we get to the end there. But next up, let's do some actual live tooling. So you saw that the turning was very easy to put on. It's just one plane, easy to set up. But I don't have to jump into another side of the program or anything. If I want to start milling, I can just go between milling and turning all I want. I can reorder the processes if I don't like, or the operations if I don't like the order that they're in. Anything like that is doable. It's very easy, and then reposting the code is very easy as well. So I'm going to go ahead and rough this hex out. So in this case, I'm coming in on the face. And you'll see the tool is very easy. It's once again, this is now a milling tool. But again, you're just picking the form. You're putting in the dimensions. Again, offset's a big deal, obviously, and tool holder can be in there. I don't have tool holders because the machine sim tool blocks are taking care of that. But this is the main thing I wanted to bring up, where you just have a little indicator where you want to point towards. And these ones kind of allude to some of the more advanced machines where you might have something like a sub spindle or a lower turret. Right, so I have this guy pointing towards the face. And in my actual process setup, this particular machine, I can always make more CSs, but this one has CSs created already, and you can see that this is going to be done on the XY plane instead of the ZX plane. All right, so I'm going to go ahead and say, hey, get on the XY instead, please. And you can see that I've also switched the mode to slice plane, so I can easily get this geometry. Maybe I'll just go in and you know, start here and end there kind of thing. Again, you can put them in precise amounts and all that kind of good stuff as well. And when I do that, you can see it's deployed processes. And again, everything I'm throwing in are paired up, but they don't have to be. If you want to separate your roughing and finishing one by one, that's fine too. Or you can throw them all in there if they match, if they go together. Things like, you know, spot drill tap, and you never have to look up the pilot hole size anymore. And loads in with all of the right feeds and speeds and everything. Right, so nice and easy. And that guy's going to hang out there, and once again, I can come in and simulate. And this is where we have a specific option that we could go between. All right, so why don't I go ahead and skip to this operation? All right, so I could do a couple things. I could either select to just go all the way to this operation or buffer to this operation, or I could just simply play just the selected operations here. All right, and I'm going to watch it. And this is having to do with rotary milling. So this allows you to watch it as is if you want. All right, or I could go ahead and set it so that the machine is actually doing the motions it would do. Right, and you have this, which would be the C-axis interpolating, and you're doing more rotary milling or polar and cylindrical. Or if I wanted to change that at all, I can just come in here, and literally it's just one selection here where I can set it to the position instead so that it does X, Y, Z, if possible. You can say no axis movement. Didn't have to repick anything, didn't have to do anything special other than that one option that I changed. All right, now it's using the X, Y, and Z, and you might use one day and one the other. I mean, it depends, and if you don't have a Y-axis, absolutely a must. So that hex looks good. I have the rough and finish process there, so that should be good and ready to go. We've got a couple more holes on the face here. I'm going to come in here, do a little thread milling. And once again, just making sure we're on the XY plane. I have a drill, I have a chamfer, and I have a thread mill. I already have the profiler selecting what I need, so I'm going to go ahead and just grab those, do it. And there you can see those three that went together and were already set up maybe from last time. I've just made my life a lot easier. Again, same kind of thing too. Where I'm coming in here and I can simulate and I can watch and see if I'd like to change anything about it. But this again would be a good one to do the polar and cylindrical, keeping that turret up in the positive here and coming in, spotting, and then you can see here the full profile thread milling, which is another thing totally supported, very easy to use. Again, just making a thread mill tool, dropping it down, choosing thread milling, filling in all of the parameters. That's using the C-axis or the positional once again. So this part's coming along. That's about all the face work I'll do on there, but obviously we could be also coming in on the OD, so I'm going to go ahead and load something for that. And the first one is the pocketing on the outside. Once again, if we take a look at the tool, nothing really different about the tool other than it's a smaller tool, of course, but we have it sticking towards the OD now. And the worst thing that can happen is it makes the tool path and then you simulate and you see that the tool is the wrong orientation and you change it. Or a warning comes up and says the orientation couldn't be achieved. So that's not a problem at all. Now, if I look at my planes here, I don't actually have a plane that would angle to that pocket. Right? If I take a look at any of these guys, I'm either going to have to use an angle option that I'll show you in a second, or I can go ahead and make a new CS plane. And it's very easy. Again, this CS list, I'm just going to hit new CS. And maybe I'll go ahead and call it pocket here. And I'm going to bring out, open the CS palette, which actually creates the CS or moves the CS, I should say. And I'm just going to go ahead and align it there. You can see, depending on what you have, there's a negative and there's a positive, right? So I can always also flip. I could go to the other side, whichever is going to work for me in that situation. I could also do a rotate, maybe a 180 rotate around. You can see all I'm doing is I'm putting that so that it's on the positive side. I'm going to do it off the ZX plane. Let's do that one there. Pocket. My profiler adjusts to it. So I can again reposition that to take another slice of whatever I want to cut. And then inside of my process, I can say, hey, there's my pocket CS, or whatever you want to call it, the angle that it's coming in or what it's doing. Select that. And also notice that I have a duplicate here. Right, so maybe I'll just do it without the duplicate first. Oh, and I still have a duplicate in the other one, but you'll be able to see here. I'll turn them off just to get the point across. But it's basically however many times that pocket happens around this part, I can always say, hey, duplicate this same feature around however many times I want by whatever angle. And it makes it really quick to create instead of doing another CS, even though that's pretty quick too. So if I said 1 times 60 in these cases, you can see that's been duplicated and it will cut both. Now the order depends, but you can always reorder on the op side, or I can also put specific C angles to start from. So in this case, I actually have those same pockets on this side, and those are 180 away, so it's possible I could maybe do a 180 here and do a do it instead of a redo to create 2 more processes here. And I forgot the 180 in the other ones. So no matter what you were doing here, I mean, however many angles, if it's a weird angle, if it's not equalized all the way around, there's a chance that you can get to it using this, or obviously the coordinate systems are always there and very easy to place, especially if you have a model. Now, one of the last things I'm going to show you here are the rotary milling once again, and I actually have some text in a work group here. Here's some text going along there. I'm just going to switch over to that coordinate system and basically wrap this text around because I want that to be written around with rotary milling. And very easy. Once again, it's just like you're doing a straight contour, but you're going to be doing a polar and cylindrical. If I load up this rotary engraving, it's a normal, just regular contour, but I have polar and cylindrical. And maybe I'll do that one again, 180 from there. And selecting, I mean, there's lots of different methods of selection. I'm going to just turn off the solid, let's say, and select like that. And say do it. That's going to write them all down and wrap them there around like so. So I'm going to go ahead and play out to that. Maybe I'll use this one for that. Again, I'm going to start or stop before operation 19, let's say, and I can turn that on, and that means that it's just going to play as fast as I want. And then it will stop at that operation. There's also a way to buffer it in so that every time you rewind, it goes to that operation. Here you can see it coming around and doing some rotary engraving. And there was nothing special about the text. There's a very quick text creation tool in the geometry palette. You just put it at the right radius. It doesn't even have to be wrapped. That's what polar and cylindrical does. Now there it's going to go ahead and engrave around there. And then because I duplicated one at 180, it's going to go ahead and cut on the other side as well. Now this part's pretty much done. So all I need is the part off now. So going back to the turning, again, I can just make a turning tool or load a turning tool, and there's no kind of change in where I am or what I'm doing. This one I saved with a tool holder, so that's why that came up there. But again, if I don't want it up there, I just throw it in the body bag and it's safe for when I need it. Probably going to go ahead and grab my slice spun body again. I'm on the correct plane. I have a little feature here. I mean, you could leave material maybe and finish up after, but maybe I'll come in, go this direction, down a little bit, maybe make a little bit of room for myself. And I could go ahead and maybe come in here. And different things like lead-ins, lead-outs, all that kind of stuff is totally doable. I could arc on or anything that you want there. There you can see I have some part off thrown up there. And that's essentially my program. So why don't I go ahead and watch this one, and then I'll bring up the machine sim again real quick. Notice I didn't rewind or anything like that, so now it's going to just go ahead and move along. Oh, my bad, yeah. I did go a little bit too far past it, it looks like. I can throw off there. Let's do 20. Again, I do know plenty of people that when they're programming, they are programming with all of the machine sim and tool blocks and everything there. They may have that set up. I have a lot of people I know that have a specific setup and they don't touch it after that. All right, so that's easy to do with a template file. Thumbs, parts off. Looks good. Once I'm ready, I have program error checker that I can do. There's collision checking. I can set it to tell me if something hits something else or anything like that. And then when I'm happy with the program, I can go ahead, load up a post processor and post that code. And the post processor is customized for your machine. So there's lots of things that you can do there and different machines it can support. So why don't I bring that up again? I'll save this guy. And I'll bring up the machine sim once again and just play that for a second. But the, you're seeing a mill turn here. And this machine actually has a sub. So that's why you can see this. I'm just not using it. But I'll bring up another machine sim there that shows, you really can go up in advanced kinematics. There's GibbsCAM can support so many different configurations and different kinds of machines. It's all just about configuring the MDD, which is the machine side, and the post, and just getting things set so that it makes the right code every time. Matches the simulation perfectly. You can see all the tool blocks. This is the whole machine in here with a control and everything like that. And you've got tool blocks on the turret here with the tools in it. It's very easy to add the tool blocks as well, especially once they're in there. it's just in the tool. You click, you say add tool block, and you pick the one you want. And the hangouts can come from that. And anything I can do the cutaway or anything like that, here I'll move it along a little bit. You can see the C-axis doing its thing, thread milling, and then doing the pockets. Things are pretty close. I want to make sure that those things aren't hitting. So this is a good way to do it without having to sacrifice anything or having a heart attack at the machine. There's the engraving, and then the part off. Once again, this one has a sub spindle. I'll bring up another one here that also has that. Just a couple different options you could look at. And this would be more considered MTM. So I'm sure there will be or has been some kind of a webinar or video on that online. But here you can see a machine with a programmable tailstock here, and it's got an upper and lower turret. It's doing pinch turning. It has wake codes. Things are overlapping operations to save time. So that's all pretty much equally as easy, I would say. It's everyone has to learn something, obviously, but it's all supported, postable, full machine sim once again. It's a beautiful thing. All right, so that's really what I had to show you guys here. I'll end just with the axis. That was one that was requested here. So having a full milling head inside your lathe. So I'll bring that up and then we'll move along. So here you can see the axis here that can access the two spindles. There's a sub spindle here. There's a turret there as well that can be used. Everything can be synced up. You'll see some elliptical turning here. Where it's using the y-axis, it's turning a shape, not just something that's concentric. And it's going to turn that. It's going to turn some more. The sub's going to come in, going to grab it, going to go over. It's going to machine on that side, and it's all fully simulatable and collision checks and everything. All right, so hopefully that looks good. Everything made sense to you guys, and I'm going to go ahead and open it up for questions now and see where we get there.
Well, hey Dylan, this is Bart. Can you hear me okay?
Yes, sir.
Hey, and I called you Dylan. Sorry, Brandon. Hey,
That's okay.
Thanks for doing a great job showing how easy it is to program a simple mill turn part in the GibbsCAM environment. And also at the end showing how GibbsCAM can grow with your machine. So if in the future you end up getting a machine that's more involved, for example, has a B-axis head or a tailstock, you just add a module or so onto GibbsCAM and you can program those machines as well. We do have a few questions. So what I'm going to do is I'm going to read the questions that we have, and why don't you go ahead and answer them, or we'll answer them together. The first one that I'm going to ask, I thought was a real good one, because this part looks like it could be part of a family of parts. So we have a question that says, can you automate the programming? In other words, what are the different ways we could automate programming of a part or a family of parts like this in GibbsCAM?
Yeah, I'd say, I see a lot of people do copy the file and then bring the new part in and take all the operations and put them on the new part. But if you're looking for real efficiency, I'd say a family of parts macro is probably the best bet, where literally the macro is like instructions to GibbsCAM. So it can run on variables. You could have maybe the print opens and you're changing dimensions there, and then it would suck all those in, and it would literally draw, model, make all the tool path and everything based on whatever you had, going on as far as tooling and all that. All the processes are adjusted to the new part. And there's a great video we have on our CAM Solutions page too. It shows that going on, where it's just literally a click of the button. Once you enter the dimensions, You see it flicker, flash, you see everything happening on screen, and a couple seconds you're posting. So definitely a macro, I would say, is a good call for that. Probably the most efficient. Totally
Yeah, I would agree with you. Yeah, I would agree with you. Macros are definitely a great way to go if you got family of parts, and those can be easily created either by the end user, or they could work with their reseller to have those created. I would also say another great way to do automation that's completely within the hands of the user would be the use of saved processes. I still say I think saved processes are a highly underutilized way to automate GibbsCAM, and you showed that a couple times in your presentation. So saved processes is a great way to work if you're not already doing it.
I agree. Saved processes are great for even not for family of parts. Absolutely.
Yeah, exactly. That's a very good point. Not just for family of parts, for anything that you do similar machining from part to part. Let's see. Here's a more general one. What solids formats or CAD formats are supported in GibbsCAM?
Well, there's quite a list. I mean, you can expect all the major ones like SolidWorks, CATIA, things like that are going to come in. Parasolid, absolutely. Any software that I've ever run into that doesn't have the direct import of their native file can export something like an IGES or something else that Gibbs can bring in. Now, I will say that there are a couple of formats that you need to pay a little extra for, but definitely it brings in most, I would say.
Yeah.
I don't have a list of them all, but I can bring it up here if you'd like.
Right. No, that's okay. I think just letting people know that we support basically every popular flavor of CAD format out there, whether it's a native format such as an Inventor file, a SolidWorks file, or whatever, or if it's an industry transfer format like a Parasolid or an ACES file or whatever the case may be. The other thing that I'd say also is we've taken our ability to import files from different CAD systems to another level by doing the add-in import. So from SolidWorks, from Inventor, and a couple others, you can actually transfer your file directly from that CAD system over to Gibbs, and what that does is that offers an additional layer of interoperability between the two of them. So if you're using one of these more popular CAD systems, again, such as Inventor or SolidWorks or a few others, and you have both the software loaded on your computer, you could actually use these add-ins. Again, if you're not, work with your local reseller and they can help you take advantage of that really, really good interoperability.
Absolutely. And one more point, you can have features importing too. So things like SolidWorks, you can have features importing and do revisions that way as well. Yeah, that's a good point.
Yep, great point. Another one, they're asking about, is the tailstock advanced retract a macro, or is that a command within GibbsCAM?
That depends. So it can be set, like you can create axes that you can drive. There is also, sometimes you'll have it in the op comments. It won't be simulatable, or depends if you sync them up, but sometimes they'll be triggered. If you look at the operations, you can put comments. So if it's not dead set in the post and simulation and everything as an axis that you can add, then you can always put in whatever, comments or any kind of code that would activate it as well.
Right. So there's the manual way of doing it, which you just described too, but also I believe it could be set up as a utility op.
Absolutely.
Is that correct?
Yep. Yeah, you can build it in and say how much of advance is.
So to answer the question, it's not done as a macro. It's done within GibbsCAM, defined by the user. It can be put in manually, as Brandon explained, or you can also have it built into your MDD and as a utility operation. And for the people not familiar with the utility ops, the simple way to explain utility ops is that is the way that GibbsCAM uses utility operations to control non-cutting motion in your machine. So bringing in a tailstock, for example, is a non-cutting motion, and a lot of machines today have a lot of non-cutting motion in them, and GibbsCAM uses utility ops. And by doing utility ops, you can graphically display and simulate all that non-cutting motion. A lot of other systems can't.
Yeah, you see it, the quills a lot too on milling machines. Yeah.
Correct. Yep. Let's see. Just reading through a couple questions here. We'll do a few more. What kind of tool library is there? I would expand on that question and say not only what kind of tool library is there, but what tool manufacturers do we link up with?
Sure, yeah, it depends on the different plugins. So a library right off the bat, they've added things like the Helico Solutions library. There's the Harvey library as well. They basically have a list and you can filter through them by, different sizes, shank sizes, all that kind of thing. And then it can even link you to the website and then quickly imports the tool as well. There's also things like Sandvik creates something called Coro Plus that runs off catalogs. And it's not just their tooling either, but you can load in, let's say, the lathe catalog and then use that to build assemblies, tool assemblies from the pull stud all the way down to an extension or anything like that, and import them that way too, and use it to manage. And of course, the save process as well. Sometimes you can find them online as well, the save tools, but you can also save your own that you're creating. I'm happy to bring up a library on screen too.
No, that's okay. And again, if somebody wants to see this in more detail, we'll encourage them to reach out to their reseller. So basically what you're saying is when it comes to tool libraries, we have a few options there, which is build your own tool library and bring it in whenever you need it, to link to a tool manufacturer and bring in the tools straight from their catalogs online. Yeah, obviously.
Absolutely.
All right. Here's one. I don't mind answering this one. What if a company has multiple locations or I need to work from home? So there's multiple ways that we can handle that. This is really a licensing question. So GibbsCAM is licensed primarily two ways, and that's either with a hardware dongle. So whatever dongle the computer is plugged into, that's the computer that can run GibbsCAM. Or we can float it over a network. Whether that network is local, just within your own building, or if it's over a wide area, meaning you got a facility in 2 different states, you could share it over your wide area network as well. And as far as from working from home, that's also supported as long as you are set up to be able to dial in remotely. There's an old term for you, dial in remotely. But through a VPN, you can run GibbsCAM remotely by accessing your desktop at work. But there are multiple licensing options with Gibbs, and one of the things I do like for GibbsCAM that I think is rather unique is the ability to mix and match. So you could have 2 or 3 seats floating on a network covering multiple facilities, and also have 2 dongles that are dedicated to just 2 PCs. So the ability to mix and match your licensing based on your needs is a very good option to have. Let's see. Yeah, okay. I'll tell you what, this will be the last question for now, and you did touch on this at the end of your presentation, but it never hurts to reiterate this and talk about this a little bit. It says, what if the machine has something like a B-axis head, multiple flows, or sub-spindle? Can you support it? I'll let you take that initially, Brandon.
Yeah, absolutely can be supported. I mean, I've seen, I can't remember the exact number of flows, but I've seen a Swiss that had I want to say 6 or 8 flows or something like that. But yeah, they use a sync manager where you can sync the ops in each flow so that you get your weight codes and nothing, kisses each other and all that. And any sub-spindle work as well, moving the turret, like you mentioned, the utility operations, there's ones for moving the turret to specific places to wait to jump in right away, or things like pinch turning or staggered roughing where one's doing a rough cut and then the next one's just lagging behind a little bit and doing the next cut. All of that's supported, and yeah, pretty easy to use too.
Yeah. Well, and I agree, and I started off the Q&A session by saying how you showed us at the end that GibbsCAM can grow with your machining needs. GibbsCAM is one of very, very, very few in the market that has the ability to program really any complexity of a mill turn machine that you have, whether it's like what you showed, what we consider a simple mill turn, one turret, one spindle, or as you add complexity to that, throw in a sub spindle, throw in a lower turret, replace the upper turret with a B-axis milling head, or, and this is really one of our strengths, if you get into full Swiss machining, which is a completely different animal than you know, these traditional mill turns like you just showed, but GibbsCAM has the ability to support that very broad range of mill turn machines. Now, with that said, anybody that's interested in seeing, you know, what we can do supporting what we call these multitask machines, right? Multiple turrets, multiple spindles, B-axis head, Swiss machines. We did do a previous webinar, and there's a recording available for that webinar. If you want to get a link to that, just visit your reseller's YouTube page, or just obviously reach out to your reseller and they can send the link to you. Okay, I'm going to do one last look here. Let's see. That's what I'm going to do for that. That's it for questions right now. I think we're close to our end of time anyway. So let's wrap up the Q&A sessions. For any questions that we didn't get to, we'll have your reseller follow up with you directly on them. We've got them here, and again, we'll hand them out to the appropriate reseller so they can follow up with you directly. Thanks, Brandon. Thanks for everybody for attending, and be on the lookout for our next webinar in a couple months.